The next lesson that we have is lesson 3.5, solving quadratic equation by the use of the quadratic formula. Solution by the use of the quadratic formula. So our objective here will be to solve a given quadratic equation using the quadratic formula. And let's recall the quadratic equation again. Ax squared plus bx plus c equals 0. Always we should remind ourselves that a is not 0, a, b, c element real. And during the previous discussion that we had, we were able to come up with the quadratic formula by completing the square. And what we got was x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now, I'm writing this quadratic formula in this manner. X equals, and then the division line should be exactly after the equality sign. It cannot be that you will get that, or you cannot have that division line below and above the division sign. Okay, now, instead of using this immediately, let us derive this quadratic formula by another form of completing the square method. Okay, this method consists of two steps only. Step 1, we get MPE by 4A, and step 2, we get APE by B squared. Okay, so ax squared plus bx plus c equals 0. First thing we have to do is, we are going to have the constant term b transferred to the other side. So we get a squared plus bx equals minus c. Then, we are going to apply multiplication property of equality by the value of 4a here. Incidentally, the value of 4a is the same as 4 times a. So we multiply everything by 4a. Multiplying the given equation by 4a will give us 4a squared x squared plus 4ab x equals negative 4ac. And then, addition property of equality by the value of b squared. The value of b squared is the same as b squared here, so we get 4a squared x squared plus 4abx plus b squared minus 4ac plus b squared. The left-hand side now, we are ensured that that's a perfect square trinomial because of this process that we employed. So now we can write this as a square of a binomial. Here, the square root of this is what? 2ax plus square root of that is b. And I can commute this and write it in the form b squared minus 4ac. Extracting the roots, I can have this implies 2ax plus b equals plus or minus square root of b squared minus 4ac. And solving for x, this will give me 2ax equals negative b plus or minus square root of b squared minus 4ac. And MPE again will give me x equals, this is the division line, negative b plus or minus square root of b squared minus 4ac all over the coefficient 2a. So here is our quadratic formula derived by using this method of completing the square. So how do we apply solving quadratic equations by the use of the quadratic formula? What we just have to do is write our given equation in the form ax squared plus bx plus c equals 0 and identify a, b, and c. Having identified the values of a, b, and c, you just use this equation, substitute those values here, then simplify whatever is the resulting expression on the right-hand side. Let's have some exercises. For example, we have 2x squared plus 9x minus 5 equals 0. For us to use the quadratic formula, we need to write our quadratic equation in standard form. So the given is already in standard form, and we can now identify the values of a. Our a will now be 2 my b is 9, and my c is negative 5. From the formula, I can have x equals negative b plus or minus b squared minus 4ac all over 2a. Substituting here, we get b is positive 9, so we have a negative 9 there, plus or minus. This is a 9 squared minus 4 times 2 times negative 5 all over 2 times 2. Simplifying this, we have the following. Negative 9 plus or minus 9 squared is 81. Remember, this negative here and this negative here will become positive. This is all multiplication. So this will give me plus 40 all over a 4. Then we have negative 9 plus or minus 81 plus 40 is 121 all over 4. Simplifying this, we get negative 9 plus or minus, this is a perfect square, this is 11 all over 4. From it, we get our solution. The first one, negative 9 plus 11 is 2, divided by 4 is 2 over 4. The next one, negative 9 plus negative 11 is negative 20 all over 4. Now we can reduce this as 1/2 and negative 5. So therefore, the solution set to this equation is 1/2 and negative 5. Next example, suppose we have 3 over 2 n plus 1 plus n squared all over 4 equals 0. Okay, notice that this equation contains fractions. It will always be wise to have all the coefficients be integers, which means I have to transform this equation so that I will get rid of these denominators. And that will be easy for us to do by applying MPE by the LCM of these denominators. So what will be the LCM of 2 and 4? Or what will be the least common multiple? That means, what will be the least number that is divisible both by 2 and 4? That will not be 8. That will not be 12, but it's actually 4. Okay, so multiply everything by 4. We are allowed to do that by MPE. So we cancel this, and we get 2 times 3 is 6n. And this one becomes a 4. And this becomes an n squared equals 0. Arranging these terms, the quadratic equation in n will now be n squared plus 6n plus 4 equals 0. Identifying what is my a here is the coefficient of the squared term, so that's a 1. B here is a 6, and C is a 4. Again, using that quadratic formula, our n now will be equal to negative b plus or minus b squared minus 4ac all over 2a. From these values, we now substitute them in this formula. We have b is 6, so we have a negative 6 plus or minus b squared is 6 squared minus 4 times 1 times 4 all over 2 times 1. Simplifying this, we get minus 6 plus or minus. This is square root of 36 minus 16 all over 2. We can write this as negative 6 plus or minus square root of 20 over 2. Recall how to simplify square root of 20. Square root of 20 here, I can split this 20 into 4 and 5 such that one of the factors is a perfect square. So that will be 4 times 5. So, simplifying this, I get negative 6 plus or minus. Square root of 4 is 2. So, I'll take that out. 5 remains in the radicand all over 2. Here, I can factor out 2 on the numerator. So, I get 2 times negative 3 plus or minus square root of 5. From here, I can cancel the 2, and I'm left with negative 3 plus or minus square root of 5. This will be the value of my n. Or you can write your solution as minus 3 plus or minus square root of 5, or you may opt to rewrite them separately. Let's have another example. Suppose I have 1/2 x squared plus 3x equals 0. This one is in standard form also, but I would like to work with coefficients that are whole numbers or integers. So I want to rewrite this equation such that I will not have a fractional coefficient. So I will apply MPE by 2, and I will get x squared plus 6x equals 0. Now, note that this can easily be solved by factoring method, but we are employing the use of the quadratic formula. So here we identify my A. A is 1, B is 6, and C is 0. Okay? From these values of A, B, and C, we can use the quadratic formula now. Negative 6 plus or minus square root of B squared is 36. Now, if C equals 0, this term here will always be equal to 0. So you don't need to think about what will happen to that anymore. And then we get here 2 times 1. So we get here negative 6 plus or minus square root of 36 is 6. And this is over 2. Simplifying that, we get minus 6 plus 6 is 0 divided by 2 is 0. And minus 6 plus minus is negative 12 divided by 2 is negative 6. So the solution to this equation now will be 0 and negative 6. Remember that we said before that for as long as the value of C in the equation is 0, one of the roots will always be 0. Let's have another example. Suppose we have here x minus 3 times 2x plus 1 equals 1. This is not in standard form, so we need to expand this, meaning we multiply these two binomials, and I get here 2x squared. My middle term is minus 6x plus 1x will give me negative 5x, and the third term will be minus 3, and this one is 1. Writing the equation in the standard form, I should have this equation. 2x squared minus 5x minus 4 equals 0, where I identify my A to be 2, my B to be negative 5, and my C is negative 4. Using the quadratic formula, I'm going to get negative B plus or minus B squared minus 4AC all over 2A. And be careful of the negative sign of B. In the formula, we have a constant negative there, and then the P has a negative here, plus or minus, and then this B here, I will have to square the negative 5 squared minus 4 times the value of 2, and C is negative 4, and 2 times 2. Okay. Simplifying that, I have here negative and negative will be a plus 5, and on the radicand, negative 5 times negative 5 will give me plus 25, and then this is negative and negative, this will become positive. 4 times 2 is 8, times 4 is 32, all over the denominator is 4, or this is 5 plus or minus square root of 57 all over the 4. 57, what are the factors of 57? Is one of them a perfect square? I don't think so. So we have our answer as 5 plus or minus square root of 57 all over 4. These are the roots of the given quadratic equation. Let's have the last example. X squared minus AB equals BX minus AX. This one is quadratic in X. So we have X squared minus AB equals BX minus AX. we want to transform this to the form ax squared plus bx plus c equals 0. Okay, so let's have one side equal to 0. We get here x squared minus ab minus bx plus ax equals 0. Okay, there are two terms that contain x. That means we have to group them. Let's say I can now rearrange my terms so that I will have here x squared plus, and these two terms that contain x will be there, and then plus negative ab equals 0. Okay, so I have now x squared. I can factor out x here, and I will have negative b here plus a. And I have here plus negative ab equal 0. So therefore, my equation now may be written as ax squared plus bx plus c equals 0, where this a here is equal to 1, and my b here is the whole thing here, and my c will be this. I'm using this form of the quadratic equation not to confuse it with the formula which involves the small b's and small a's and small c's. Therefore, I can now write my equation in terms of those coefficients capital A, capital B, capital C as what? Negative b plus or minus b squared minus 4ac all over 2a. Okay, substituting here, we get my value for b will be this expression here. So I'm going to have negative of negative b plus a plus or minus square root of b squared is negative b plus a squared minus 4 times a is 1 and times c is negative ab all over 2 times 1. We are left to simplifying this expression here inside. Okay, let's have it on the side. So what is negative b plus a squared? I can write this actually as a minus b squared, and I have here a squared minus 2ab plus b squared. So this expression here can now be written as what? A squared minus 2ab plus b squared. And if I multiply these two here, I'm going to get a plus 4ab. And then this one I can have it as b minus a. Okay? Now, simplifying this, actually, I will have that as a squared minus 2ab and 4ab will give me plus 2ab and then plus b squared. Note that the simplified form of this radicand here is a squared plus 2ab plus b squared. This is actually a perfect square trinomial which is written as a plus b squared. So that this radical here, okay, all over 2 here, so that this expression here now can be written as b minus a plus or minus square root of a plus b squared all over 2. Okay, so continuing it here, our x now will be b minus a plus or minus, what's the square root of a plus b squared? It will be a plus b all over 2. So I can have my x1, the first root will be b minus a plus b all over 2. And x2, the second root, will be b minus a minus b all over 2. Simplifying this, we get minus a and a is 0, b and b is 2b. This is 2b all over 2, or I get a b here. On the other hand, b and minus b is 0. Minus a and minus a will give me minus 2a. But this one is over 2, we get a negative a. Hence, my solution to the given equation will be b or negative 8. So here we go. Using the quadratic formula requires you just to memorize the formula. What's the formula again? X equals negative b plus or minus square root of b squared minus 4ac all over 2a. You should be able to derive that formula using the completing the square methods that we have shown you. There are two ways of deriving the quadratic formula. Thank you.